Welcome to this explainer. Today, we are going to build your math confidence by breaking down a topic that honestly causes a lot of unnecessary panic. Yep, we are talking about quadratic equations. But don't worry, we're going to tackle this step by step using pure logic and super simple integers. No confusing jargon, no skipping steps. Just a really clear, structured journey that will prove to you once and for all that these equations are definitely not mathematical monsters. They're actually just elegant little puzzles waiting to be solved.
So, here's our roadmap for today. First, we'll clearly define what a quadratic equation is. Then, we'll solve a few using simple intuition, learn how to factor out a common term, take on the general formula, and finally, we'll see how quadratics actually show up in the real world. Let's just dive right in.
Okay, part 1. What is a quadratic equation? Before we even look at any fancy formulas, we need to define the core concept we're tackling today. I want you to use your pure mental power to answer this quick question. What unknown number multiplied by itself gives you 9? Take a second. You probably immediately thought of the number 3, right? Because, obviously, 3 times 3 equals 9. But, in the world of quadratics, there is always another hidden reality. And this perfectly illustrates the concept of two paths. You see, both a positive 3 and a negative 3 work perfectly here, because a negative 3 times a negative 3 also gives you a positive 9. This right here is the absolute fundamental heartbeat of quadratic equations. Because multiplying two negative numbers creates a positive result, these equations very often give us two completely valid answers.
Now, formally speaking, any quadratic equation can be written in this standard form. ax squared plus bx plus c equals 0. Look, I know the letters can look a little intimidating, but don't sweat it. The highest exponent here is a 2, and that's literally what makes it quadratic. And those letters a, b, and c, they are just regular, everyday numbers that we call coefficients. The only hard and fast rule is that a cannot be 0. If it was, our squared term would just disappear, and well, it wouldn't be a quadratic equation anymore.
Moving on to part 2, solving with simple intuition. Let's see how this builds when we use incomplete equations.
Check this out. X squared minus 49 equals 0. To solve this, we just want to isolate our unknown x, so we simply bump that 49 over to the other side of the equal sign. Boom! Now we have x squared equals 49. Just like our earlier example with the 9, your intuition quickly tells you to take the square root. And remembering our two paths, we get a positive 7 and a negative 7. See? You just solved a quadratic equation step by step using pure logic.
All right, part 3, factoring out the common term. What happens when we handle a missing constant?
So here's a slightly trickier puzzle where that standalone constant term is just missing entirely. X squared plus 5x equals 0. You can't just move a number over and take a square root this time. Nope, this requires a neat little visual maneuver known as factoring the common term. Look closely at the equation. Notice that both parts share an x. We're going to visually pull that x right outside some parentheses. That gives us x times the quantity x plus 5, all equal to 0. This completely breaks the algebra down into highly digestible chunks. Think about it. If two things multiply together to equal 0, one of them absolutely must be 0. So this gives us our two simple linear equations. Either the outside x equals 0, that's path number 1, or x plus 5 equals 0, which means x must be negative 5. Two paths, two simple answers.
Which brings us to part 4, using the general formula. Basically, we have reached the boss level.
Take a look at this incredibly clean, integer-based example. X squared minus 5x plus 4 equals 0. Every single position is filled here. Our coefficients are simply a equals 1, since there's a hidden 1 in front of that x squared, b equals negative 5, and c equals 4. So how do we solve this when our basic intuition isn't quite enough?
Enter the famous quadratic formula. I know, it looks like an absolute monster at first glance, but honestly, it's just a powerful set of instructions earned through centuries of mathematical effort, from ancient Babylonian clay tablets all the way to the geometric proofs of the Islamic Golden Age. Mathematicians painstakingly built this formula so that today we can solve literally any quadratic equation effortlessly. Let's watch how easy this is when we substitute our simple integers into the formula. We're turning an abstract monster into basic arithmetic. We just pop in our 1, our negative 5, and our 4. A negative 5 becomes a positive 5. Inside that square root, negative 5 squared is 25, and 4 times 1 times 4 is 16. We simplify that to 25 minus 16, which is exactly 9, and taking the square root of 9 leaves us with a very clean, super friendly 3.
And here's that fork in the road we keep talking about. The plus or minus symbol splits our calculation right down the middle. Following the positive path, we have 5 plus 3, which is 8, divided by 2, giving us 4. Following the negative path, we have 5 minus 3, which is 2, divided by 2, giving us 1. Look at that. We have our two perfectly valid simple integer solutions, 4 and 1. You literally just defeated the boss level using simple, step-by-step logic.
Okay, finally, part 5, quadratics in the real world. Let's talk about why this actually matters outside of a math class.
Imagine a business trying to calculate its profit based on the price of its product, which we'll call P, and its manufacturing costs. The resulting math naturally forms a quadratic relationship. Check out that P squared term in the revenue row. This happens because the price you charge directly affects the number of units you sell, which ends up multiplying the variable by itself.
When this business takes their total revenue and subtracts all their costs, they land on this rather massive quadratic equation. Negative 200p squared plus 92,000p minus 8.4 million equals 0. They set it to 0 for a very specific reason. They need to figure out the exact price points where their profit hits 0. Basically, their break-even points.
Now, sure, these numbers are way bigger than our simple integer examples from earlier, but the underlying math, it is literally identical. Using the exact same step-by-step logic we just learned, whether by factoring or by plugging these coefficients straight into the quadratic formula, the business discovers they break even at exactly $126 or $334, proving that these abstract equations are actually the secret engine for solving highly practical, multi-million-dollar real-world problems.
So now that you know how to conquer these equations step by step, I want to leave you with this final thought. If you graph these quadratic equations, they form these incredibly beautiful symmetrical U-shapes called parabolas. From the curved design of a satellite dish, to the reflector inside a deep space telescope, to the arc of a thrown baseball traveling against gravity, where else in your daily life are these quadratic formulas secretly operating? Keep your eyes open, because mathematics is quite literally everywhere. Thanks so much for joining me on this explainer, and as always, keep learning.